Hey, Algebra 2, this is going to be a helper for CFR2, CFR1/CFR2 Practice 2. I'm going to do a couple of these. I'm going to do both of the CFR1 and CFR2. We'll put it in one ed puzzle and we'll go from there. All right, so let's look at here. This is graph 1. This does look a little bit different maybe from the one you have. I made a version 2 that's the same graphs, but I put a copy of the graphs on the top of each sheet just to make it a little bit easier to reference to. So let's go ahead. We'll do this one at a time. We'll do CFR stuff first, CFR1 stuff first, then CFR2. So with this, let's see what we got here. We got this graph, this nice curvy graph going on here. And it says, find the domain in the following notations. Well, first we got to figure out what the domain is. And if I look at this, I'm looking for my small y. And also, oh my goodness, I hope you guys just caught that. My small x and my big X. And what I'm doing is I'm looking at this function. If I'm tracing this function to the left, if I'm looking over here, is there an endpoint going this direction to the left? There's no endpoint. There's no stopping this from going to negative infinity in X. This is negative infinity. There's no endpoint on the left side, just like there's no endpoint on the right side of this function graph, right? There's nothing stopping it from going. I know it's going all the way this way. It's kind of going down, right? There's not going to be an X value that I can come up with that will not have a Y value with it because that arrow points that direction. So my big X in this case is positive infinity. It doesn't matter where the arrows are pointing right now. You got to think of this in terms of what's the X for domain and Y for range. So let's look at the range. Let's do the small y and the big Y. The small y and the big Y. Well, first I'm going to look, do I have any arrows pointing down, right? Because I'm going from down to up. Well, let's see. It looks like it might be here because that's smaller. And oh, wait, right here. This arrow right here is pointing down. In other words, this function is going to keep going down, 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 down. That's in Y. So what's down there? That would be negative infinity. And if I'm looking here, so this one all the way down, I've got this hill right here, but oh wait, I got this arrow on the left-hand side that's pointing up. Since that arrow is pointing up, the biggest Y I can have is going to be positive infinity. So my domain is actually here. My domain is actually all real numbers, right? My domain is all real numbers. So I can write that for inequality and kind of for set. You still need to have all this business here and here for set. And then interval notation, you just write the smallest, write the biggest. Since we don't know the numbers or the exact values for infinities, either positive or negative, we put parentheses. And then for the range, well, this one just so happens to go from negative infinity to positive infinity. So this one also, it's all real numbers for my range. So the set of all numbers in Y such that it includes all real numbers. And interval notation, once again, goes from negative infinity to positive infinity. If you're having trouble with infinity, writing the symbol, turn it sideways, kind of write a funky looking 8. There we go. Now, end behavior. This says as X goes to positive infinity, and remember we're tracing right. If we trace right, look at the right-hand side. Look at the right end of the function. On the right end of the function, where does that arrow point? If there's an arrow. First question, is there an arrow? Yes, there is an arrow. What direction is it pointing? Down. What's down? It goes down. My Y values go to negative infinity. Okay, my Y values go to negative infinity. As X goes to negative infinity, in other words, look at the left side of the function. Is there an arrow there? Yes, there is. So we have end behavior. Where is it pointing? It's pointing up. What's up? Never gets old. What's up with you? Or not much. Oh, I screwed it up. Oh, not much. What's up with you? There we go. It's pointing up, and what's up? Not much. What's up with you? There, got it right. Positive infinity. That is what my end behavior looks like on here. Now, that's for the CFR1. CFR2 is what we just did. Hopefully you've done that now. I don't know. We'll see. On which intervals is the function increasing? In other words, we take the X values and go between X values of where the function is increasing. Well, where is it increasing? Well, from negative infinity to right here, it's decreasing. It increases until it looks like 0. right? 0, because I'm doing x. So it increases from here to here, and also from here to here. So here to here is increasing, and here to here is increasing. So from -3 to 0, and from 5 to 8, it's increasing. Where's it decreasing? Where's it going down? Well, from -infinity until that -3, it's going down. It's going down for real. And then we've got from 0 to 5, it's also going down. Because remember, we're reporting the x. We're reporting the x intervals. So between here and here, well, I mean, grab a different color here. So between here and here, it's going down. Between here and here, it's going down. And from here on in x, it's also going down. So it's going down from -infinity to -3, and from 0 to 5. Oh, I'm sorry. Did I just hold on? I already did that one. And it's also and also from 8 to +infinity. I got excited, guys. I got excited. Relative or local maximums. Once again, if you remember back from the guided notes, those are the hills. How many hills do I have? I've got a hill here, and I've got a hill here. So I need to report the x and y values in this point. Remember, up here, these were intervals. Down here, these are kind of coordinates, right? So the value is 5 at x equals 0. You could have also written 0, 5 because that's a coordinate point. The other hill we have is right here. The y value is 0 at x equals 8. Remember, hills are where it goes from increasing to decreasing. We have 2 of those. The endpoints will never be maximums or minimums in terms of relatives. We are just looking at the hills or the valleys. Again, you could have also written this one as 8, 0. Where are my valleys? How many do I have? I have a valley. Well, I got a valley right here. Right there's the bottom, and a valley right here. I've got 2 valleys. So that's -5. Again, these are our valleys. -5 at x equals -3, and -4 at x equals 5. You can write these as coordinate points. Understand that these are coordinate points and not intervals, though. You could have written this as -3, -5. It's a bad looking 5. And at 5, -4, right? Here and here. Now, x-intercepts are zeros. Where does it cross the x-axis? Looks like it crosses 1, 2, 3. It touches there. So it crosses or touches, right? 4 times. That happens at -6, at -2, at 2, and at 8. Remember, I'm not putting parentheses around this group because they're just x values. It's just saying this is the x value, what happens. Why? Because we know the y value for an x-intercept. The y value for an x-intercept will always, always, always be 0. All right. Where are they positive? Where are the function values above the x-axis? Well, from -infinity until -6, these function values are hanging out above the x-axis. It's also hanging out between -2 and 2. And in this case, there's no other place that it's hanging out in the positive range. Now, this first one's going to be a little goofy. I will give you this for the negative values, but it's negative from -6 to -2, and from 2 until 8, because at 8 it is 0. All right, so 0 is not positive or negative. I'll try not to do that to you in the future. This one does have this though. And also from 8 to +infinity, right? Because that it's negative. 0 is not a negative or positive number, so I really can't include that. I would totally understand if you did write from 2 to positive infinity to start with until you watch this video. Okay. An example of an interval with a positive rate of change. You could just do where one's increasing, right? I'm going to say, let's see here, from 2, x equals 2 until x equals 0, because that would be right here. That's a really bad line. From right here to right here, from here to here. That would be a positive rate of change. So my example, and again, these are examples. Your answers may vary greatly from what I'm doing, but as long as it's a positive rate of change. So from -2 to 0, that's an interval with a positive rate of change. A negative rate of change, how about from 0 to 2? That would give me a negative rate of change. So my example is from 0 to 2. And then we've got to find a negative. I'm sorry, we already did negative. We got to find a 0 rate of change. What I'd like to do for the 0 rates of change is do a horizontal. So what I'm going to do is pick 2 x-intercepts. How about here? How about from 2 until, let's do this one, from -2 to 2. If I draw a line between the values of -2 and 2, I get a horizontal line, which gives me a 0 rate of change. So here's an example. That was fun. An example from -2 to 2. And there's a ton of them, right? I could have gone from whatever this value is to this one, to this value, x value. That's a rate of change of 0. Okay. All right. So that is how we take care of those. Let me find one real quick that does not have an end behavior on one side, and we can take a look at that. All right, we're back with graph 4. Graph 4 does look a little goofy here. It's got this closed end point on the left-hand side, but an arrow on the right. Arrow on the right. So let's go ahead and start here with CFR1, our domain range and end behavior. Our domain, well, let's look. Do we have an arrow on the left? No, we don't, in fact. We have an end point, a stopping point on the left. My smallest x value is -7. And it includes -7 because it's a closed in point. My biggest x is going to be positive infinity because this arrow will keep going down. I can still have values out to positive infinity that will give me a value in y. My big X, positive infinity. My headset's not happy with me. Okay, my small y, well, let's see here. I've got this point, but I've got an arrow pointing down. So my smallest y is pointing down. That's going to be negative infinity. And my biggest y value, well, that's going to be right. Well, there's no values above this. I think it touches 5. My big Y is 5. I like that. I like that. Okay. So now I can write these things. Inequality notation. I'm going to write it like this. I'm going to say that X has to be bigger than or equal to -7. It's got to be at least -7, but it can be greater than also. It can be -7, but it's got to be greater than also. So for set notation, you could have also written the set of all numbers in X such that X is greater than or equal to -7. And then for interval notation, once again, you write the smallest, -7. You write the biggest, positive infinity. Can it equal -7 exactly? In this case, yes. And since it can, we put that square bracket. Can it ever equal infinity, positive or negative? In this case, or not in this case. In any case, no. So we put a parenthesis around that because you don't know the exact value. There's no exact stopping point for infinity. Now, inequality for the range is going to be a little bit different because my biggest value in y is 5. My smallest is negative infinity. So I've got y and 5. I think it touches 5, but it doesn't go above 5. So it's got to be less than or equal to 5. Well, I just said that. That's going to work. It has to be at least less than or equal to 5. Now, if you don't think it touches 5, that's fine. Make all of your notations say that it doesn't touch 5. I think it does, so I'm going to keep it like this. My set notation here will be the set of all numbers in y such that y is less than or equal to 5. And again, interval notation, we go small to big, negative infinity to 5, cannot include negative infinity, but I think it does include 5, and I've made that known with all 3 of my notations. Okay, we've got less than or equal to, less than or equal to, and we've got this one that can equal that value. That's why we put the square bracket on here. Now we get to the fun part. As x goes to positive infinity, in other words, look at the arrow on the right if there is an arrow on the right. Since there is an arrow on the right, where does it point? And it points down. What's down? Not much. What's down with you? It is negative infinity. As x goes to negative infinity, so let's look at the arrow on the left. There is no arrow on the left. Since there is no arrow on the left, x cannot go to negative infinity. Therefore, there is no end behavior. We call this does not exist, or DNE. Does not exist. Okay? Now, I'm going to kind of whip through the rest of them here. Where is it increasing? Well, this function is going up from here until here. So from -7 to -3. And it's decreasing from -3 on. From -3 to positive infinity, this thing is decreasing. Again, we're talking about the x values. Where is it? Where are the relative and local maximums? Is the hills. All right, so now when we're looking at the hills, we got the relative local maximums. Are there any hills? Well, yeah, there's one place in this function that goes from increasing to decreasing, and that is right here. And where is right here? Well, in x, that's -3 and the y is 5. So I could say 5 at x equals -3, right? I've only got one hill. And in here, you could also, again, write this as -3, 5. But understand that that's a coordinate point, which is different than the intervals above. And here it says, what are the relative or local minimums? Well, here's an interesting case. Do you see any spots where you've got a valley? I sure don't. And since there are none, we write does not exist. Does not exist. Or DNE. Does not exist. Kind of like end behavior, right? Does not exist. What are the x-intercepts or zeros of the function? Where does it cross the x-axis? Well, it crosses at -7 and 5. And where is it positive? Well, it's positive from -7 to 5. And that's why we put parentheses around, because it doesn't include -7 this time. So it's positive from -7 to 5. And then it's negative from 5 to positive infinity. Okay. And here's some nice, a positive rate of change. You could also write the same as an interval that's positive. It's going from, I'm even going to say it. So I'll go from here to, I'll just do from, well, that's what I want to do. I'll go from here to here, from -7 to -3, right? That's a positive rate of change. So from my example, it's from -7 to -3. You could pick 1,000 different ones. You could pick from -6 to -4. That'd be a positive rate of change also. Our next question is, I think it's a negative rate of change. I'm going to say from x equals -3 to x equals 2, because that would also be a negative rate of change. So my example is from -3 to 2 of a negative rate of change. How about that 0 rate of change? I'm going to go from here to here, because this would give me a horizontal line, a 0 rate of change. That looks like from -5 to 0. From my example, from -5 to 0. Are there any other ones? Yeah, absolutely. Your 2 x-intercepts could have been one, between the 2 x-intercepts. but that's just the one I decided to choose this time. All right, we got one more thing that I'm going to throw in here. One more thing I'm going to throw in here. On the last page, this is your 3-level for CFR1. Graph the following functions with the given limited domain. Write the range in the same notation as the domain. So in other words, we've got this line. In this case, it's going to be array because it's going to end when x equals 4, but it goes on, it goes on to negative infinity in x. Okay, so here's one way to think about it, right? When x is 4, what is f of x? What's the value there so we can get this point? So if that's 4, so the value of the function when x is 4 is 2 times 4 minus 3. 8 minus 3 is 5. So I plot the point 4 comma 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And that's a closed point because of that bracket. And again, remember, this is interval notation. So I'm going to want to write the range in interval notation. And this function, it's a line, right? I could use my slope to find another point. Well, the function doesn't exist to the right of 4, right? That just doesn't exist. There's no more values out there. So I could think about it like this. My slope is positive 2. I could go down 2 and left 1. That would still give me a positive slope. Down 2 and left 1. Down 2 and left 1. Draw your line. Ooh, that's not even close, but we're going to do it right there. And it goes on forever to the left because it goes to negative infinity. And if I write the range, my range, the lowest value I have in range is negative infinity. And the biggest value I have in range is 5. It can equal exactly 5, but it cannot equal negative infinity. So now you've seen 2 examples of CFR1 and CFR2 and the 3-level example for CFR1. Hope this helps. Keep asking questions. Keep it up. You guys can do this. Take care. Have a great day.